There is a new and emerging engineering sphere that is becoming increasingly popular called genetic engineering. So what is genetic engineering? To be exact, genetic engineering is the deliberate modification of the characteristics of an organism by manipulating its genetic material. This field has many possibilities, and in order to keep the population safe from possible ill effects of this technology, many regulations on the subject have been issued. Are these the right regulations, considering laws have been largely influenced from the public and not from a scientific standpoint? We will discuss this as we dive deeper into the regulation of genetic engineering. Humans have been genetic engineers long before we even knew what a gene was. They could give living things new traits, sweeter kernels of corn, flatter bulldog faces, through selective breeding. And as time progressed, genetic modification only became easier and easier. For instance, by 2002, molecular biologists learned to delete or replace specific genes using enzymes. Unfortunately, the process was expensive and complicated. However, that soon changed with the discovery of CRISPR, which uses the Cas9 enzyme to cut the DNA like a pair of scissors and allows scientists to then turn specific genes on or off. CRISPR has changed the game as it can cause changes to the DNA without causing errors to it and even change things once thought to be impossible. This year, CRISPR was used to eliminate the genes for HIV in rats that were infected with the virus. CRISPR, as well as other genetic modification techniques, are responsible for quite a few amazing products. One such product is the Flavor Saver tomato, which remains ripe for longer due to the insertion of PG antisense DNA. There is also genetically modified rice and corn that can better resist pests and bacteria and increase the nutritional benefit. Because of this, GM food products could lead to an 80% reduction in pesticide use and an 8% increase in crop yield. Lastly, genetic engineering has progressed to organisms such as mosquitoes, which are being modified so they are resistant to diseases which they often spread to humans, such as malaria. This is truly revolutionary, but also heavily debated. Currently, genetic engineering is regulated by organizations such as the USDA's Animal and Plant Health Inspection Service, the U.S. Environmental Protection Agency, and the U.S. Food and Drug Administration. The APHIS regulates organisms and products that are known or suspected to be plant pests or to pose a plant pest risk, including those produced through genetic engineering. The EPA regulates the sale, distribution, and use of pesticides in order to protect health and the environment, regardless of how the pesticide was made or its mode of action. This includes regulation of those pesticides that are produced by an organism through techniques of modern biotechnology. The FDA regulates all plant-derived food and feed, including those developed through genetic engineering. All food and feed, whether imported or domestic, and whether derived from crops modified by conventional breeding or by genetic engineering, must meet the same safety standard. However, despite these regulations, companies are taking advantage of new methods of genetic engineering in order to lower costs and circumvent these regulations. An example is not using bacteria to insert new genes so it technically doesn't contain foreign genetic material. Another example is a new process known as CRISPR. However, CRISPR is especially prone to making off-target mutations, and while biotech companies should do DNA sequencing to catch these mutations, not much regulation exists in this area so that they do. By using technical loopholes, crops and organisms that are clearly genetic engineered are escaping regulation, and as no one is required to look at these new products, all sorts of ecological impacts are possible. On one hand, pros of increasing regulation include increase in safety, as it will no longer allow people to easily circumvent and evade current regulations, whereas cons of increasing regulation include they will hurt small companies as regulations cost money that said companies are unable to pay. The fact that most processes have already been proven safe, and many studies have found that the insertional effects from genetic engineering are a similar level of risk as DNA insertions from natural processes. And lastly, these regulations may limit progress, as it will be more difficult to get new products approved and developed. As regulations on genetic engineering are outdated and regularly circumvented, a change must be made. This change must be made not only for our current but for our future safety. However, changing the regulations on genetically engineered products should not also mean an increase in regulation. Regulations simply need to adapt to better suit the developing techniques for editing.